फिर सेम इसी पर वेब जोन में इसी तरह का वुडन ब्रिज बना जो 100 मीटर का स्पान का, मान 100 मीटर लेंथ का वो बना। वो देखिए वो ब्रिज इस तरह बना इसी स्केच पे। ये है लगभग सेम है जो स्केच लियोनार्डो दा विंची ने बनाया था, फर्स्ट कॉन्सेप्ट था उनका, सेम इसी तरह का ये वुडन ब्रिज बना। उसके बाद फिर टिम्बर से हम लोग स्टील में गए। 1840 में जो ट्रांजिशन पीरियड था, टिम्बर से स्टील में गए और हमारा ब्रिज कंस्ट्रक्शन जो है इंटायरली चेंज हो गया। सेवनटीन 1734 में जर्मन आर्मी जो था पहला एक चेन से ब्रिज बनाया, स्टील चेन से ब्रिज बनाया। वो है फर्स्ट रिकॉर्डेड यूज ऑफ आयरन इन ब्रिजेज वाज चेन ब्रिज बिल्ट इन 1734 बाय जर्मन आर्मी। फिर स्टील में हमारा सबसे पहले कास्ट आयरन आया, तो कास्ट आयरन, उसके बाद रफ आयरन आया। तो कास्ट आयरन का टेंसाइल स्ट्रेस ज़्यादा होता है कि रफ आयरन का? रफ आयरन का टेंसाइल स्ट्रेस ज़्यादा होता है, इसलिए रफ, फिर बाद में उसका कॉम्बिनेशन किया गया कि कंप्रेशन साइड में हमारा जो है कास्ट आयरन को रखा गया और टेंशन साइड में रफ आयरन को रखा गया। इस तरह हमारा ब्रिज का स्पान का लेंथ बढ़ा और रेलवे वाले उसको यूज किए। फिर ये बेसेमर हैं, ये इन्होंने 1956 में स्टील को पेटेंट किया। स्टील बनाने के जो है प्रोसेस ऑफ मेकिंग लार्ज क्वांटिटी ऑफ स्टील इकोनॉमिकली, इसका इन्होंने पेटेंट करवाया और इससे हमारा ब्रिज का, ये देखिए नीचे जो ब्रिज है ये सबसे उस समय का लॉन्गेस्ट ब्रिज था, लॉन्गेस्ट स्पान वाला ब्रिज था। फर्थ एंड फोर्थ कैंटिलीवर ब्रिज, उसका स्पान 520 मीटर। तो पहले स्टील में हम लोग 100 मीटर 120 मीटर तक गए। इसके बाद इनका जो स्टील बनाने का जो प्रोसेस था उसमें स्टील में और ज़्यादा स्ट्रेंथ आया और उस वजह से हमारा स्पान बड़ा हुआ और जो 520 मीटर स्पान, लंबा स्पान का हुआ। अभी हम हावड़ा में हमारा 1943 में स्टील ब्रिज बना हुआ है, स्टील ट्रस ब्रिज बना हुआ है जो कैंटिलीवर ब्रिज है, वो 457 मीटर लंबाई का है। ये a very substantial advance in the understanding of theoretical analysis of the load response of the structural system of suspension bridges was made by the 20s of the last century, and many elegant bridges were built like Lindenthal's Manhattan Bridge 1909 में 450 मीटर स्पान। उसके बाद बना फ्लोरियानोपोलिस ब्रिज जो 340 मीटर। फिर देलावेरे ब्रिज, रिवर ब्रिज बना 530 मीटर स्पान का 1926 में। द बिग लीप फॉरवर्डेड कम इन 1931 विद द कंस्ट्रक्शन ऑफ जॉर्ज वाशिंगटन ब्रिज। ये जॉर्ज वाशिंगटन ब्रिज जो है एक नया तरह का ब्रिज बना, एक्चुअली वो सस्पेंशन ब्रिज था और उसने एस्थेटिक को बढ़ावा दिया, एस्थेटिक लुक को बढ़ावा दिया। और उसने जो दिलावर का जो 530 मीटर स्पान का जो ब्रिज था, जो उस समय का सबसे लॉन्गेस्ट स्पान था, उसका रिकॉर्ड ब्रेक किया और ये 1000 मीटर स्पान 1060 मीटर स्पान लेंथ का ये ब्रिज बना। ये इसके बारे में बहुत सारे ब्रिटिश और जर्मन जो पोएट हैं इस ब्रिज के बारे में अपने अपने पोएट्री में इसका जिक्र किए हैं। तो ये इतना खूबसूरत ब्रिज था। फिर न्यूयॉर्क में अमांस जो है नैरो ब्रिज बनाए 1964 में, जो जिसका स्पान लेंथ था 1 किलोमीटर 300 मीटर। ये लैंडमार्क इन द हिस्ट्री ऑफ लॉन्ग स्पान सस्पेंशन ब्रिज बिल्डिंग ये था। अब लंबा स्पान ब्रिज बनाने का एक तरह से वर्ल्ड में समझिए कि होड़ लग गया कि कौन कितना लंबा स्पान बना रहा है। और वो लंबा स्पान सारा ब्रिजेस जो था उस समय किसका बन रहा था, स्टील का बन रहा था, ठीक है, और सस्पेंशन टाइप का ब्रिज बन रहा था। और इसी में एक टैकोमा ब्रिज था जो कोलैप्स हो गया। उस समय एक आंधी आई, एक विंड 64 किलोमीटर पर आवर का स्पीड से वहाँ आया, और वो शायद संडे का दिन था। वहाँ लोग वीकेंड एंजॉय करने के लिए उस जगह पे थे, इसलिए उसका वीडियो आज भी अवेलेबल है। तो उस विंड स्पीड से वो ब्रिज कोलैप्स हो गया। तब से एक नया कॉन्सेप्ट आया कि हमको जो ब्रिज का डेक है वो ऐसे फ्लैट नहीं बनाना है, वो उसका शेप एरोडायनामिक शेप रखना है, एरोफाइल शेप का रखना है। और वो जो आदमी लेकर के आए, जो महान आदमी लेकर, ये टैकोमा ब्रिज है जो कोलैप्स हुआ था। विंड के चलते रिजोनेंस हुआ, रिजोनेंस के चलते मैंने एक्सेसिव वाइब्रेशन, और लगभग वो उसका जो हायर इंड था फेल का और लोअर इंड था उसमें 28 फीट का गैप माने अंतर था। तो समझिए कि एम्पलीट्यूड कितना बड़ा होगा उसका। यही प्रोफेसर लियोन हार्ड इन्होंने ही एरोडायनामिक शेप को ब्रिज में इंट्रोड्यूस किया। ये लिस्बन का टैंगस ब्रिज है, ये फ्लोरिडा का ब्रिज है सनशाइन ब्रिज। 1820 में नेवियर in opting for the classical suspension system condemned the cable estate solution as unsuitable। उन्होंने एक रेंज दिया। लियोन हर्ट ने अपने IABAC पेपर में रिसर्च करके बताया कि 750 मीटर से 1.5 किलोमीटर तक के स्पान के लिए केबल एस्टेट सिस्टम जो है टेक्निकली इकोनॉमिक है, टेक्निकली वायबल है और इकोनॉमिकली वो फिट है इन कंपेयर टू सस्पेंशन ब्रिज। और द यूज ऑफ ए फॉर्म पाइलन which corresponding inclination of planes of cables, fan shaped smaller diameter cables, add closer spacing etc. are the new trends in the design to realize the large span। अब स्टील का तो साथ साथ चल रहा था, बीच में कंक्रीट में भी एडवांसमेंट होना शुरू हुआ। तो पहले कंक्रीट जो सीमेंट है, सीमेंटेशियस मटेरियल है, पहले कहाँ से मिलता था? लोग में जो रोमन्स हैं वो उनको कहाँ से वो प्राप्त हुआ, कैसे जाने कि सीमेंटेशियस में है? तो वेल्कनों के ऐश में वो क्या करते थे कि एनिमल का ब्लड वगैरह सब मिलाते थे और उससे वो ब्रिज कंस्ट्रक्ट करते थे या कोई स्ट्रक्चर बनाते थे। तो वहाँ से बने सीमेंट का एक तरह से समझिए कि सीमेंटेशियस मटेरियल का खोज हुआ। फिर आगे पोर्टलैंड सीमेंट आया, Concrete was first used in bridge 13.5 meter span across canal in France in 1840. हाँ, कोइजेंट थे, इन्होंने पहला जो है पेटेंट करवाया यूज ऑफ कंक्रीट. कंक्रीट बिकम द मेन मटेरियल फॉर द ब्रिजेज. उसके बाद से the search for the basis of rational concrete structure design began in the last part of the 19th century itself. Hyatt is credited to be the first established the basis of analysis of stress in reinforced concrete by stating the principle of bond. जो हम लोग स्टील में बॉन्ड, जो हमारा जो डिफॉर्म बॉन्ड वाला जो स्टील आया, ये इन्हीं का, हयाट का ही देन है. इन्होंने ही बॉन्ड पे अपना एक पेपर पब्लिश किया. वो बाय लॉयर थे. हयाट वाज एन अमेरिकन लॉयर बाय एजुकेशन बट एन इन्वेंटर बाय नेचर and was later to take patent on deformed bar. Koenen, a German mastermind, a government architect in Berlin, was commissioned to deduce the method of computation of reinforced concrete section, and he published his design rules in 1886. जो आरसीसी का हमारा स्टार्ट हुआ वो 1886 से. इन 1909 वहाँ से कोड सब स्टार्ट हुआ. जो ब्रिज के कोड्स हैं जैसे ACI, ASCE and certain other professional scientists in the US interested in reinforced concrete made its grand entry. The French Commission on Reinforced Concrete has formulated its design rules back in 1906. अब कंक्रीट आ गया, फिर उसमें एक एब्राहम्स आए जिन्होंने वाटर सीमेंट रेशियो के बारे में बताया. तो फिर वहाँ से फिर हमारा स्ट्रेंथ कैसे, माने वाटर को कंट्रोल करके सेम सीमेंट के क्वांटिटी से कैसे हम उसका स्ट्रेंथ को बढ़ाएं और हमारा वर्केबिलिटी भी अफेक्टेड ना हो. तो इस तरह एब्राहम्स के आने के बाद फिर हमारा कंक्रीट का स्ट्रेंथ जो है वाटर सीमेंट रेशियो को कंट्रोल करके हम लोग स्ट्रेंथ को बढ़ाएं. और जब हमारा हायर स्ट्रेंथ का कंक्रीट मिलना शुरू हो गया तो फिर हमारा कंक्रीट ब्रिज का भी स्पान लेंथ बढ़ना शुरू हुआ. फिर फ्रेसिनेट आए. फ्रेसिनेट ने उस कंक्रीट का जो है जो कॉम्पैक्शन है वो वाइब्रेशन के साथ वो कॉम्पैक्ट, पहले हम लोग कंक्रीट को कैसे रैम करके कॉम्पैक्ट करते थे, लेकिन फ्रेसिनेट आए, उन्होंने ही वाइब्रेट करके उसको कॉम्पैक्ट करना सिखाया. और फ्रेसिनेट ही वो शख्स हैं जो प्री स्ट्रेस कंक्रीट को हम लोगों के सामने लाए. The idea of pre-stressing conceived and put to the practice in 20th century is the single biggest happening of greatest significance in the entire history of construction on this planet. The man who first gave the form and content to this concept, the originator of the pre-stressed concrete, was none other than the greatest master designer. ऐसा होता था कि उस स्केच पे जो इंजीनियर्स होते थे वो उस स्केच को हूबहू कंस्ट्रक्शन में उसको माने नहीं ला पाते थे. उनका स्केच इतना कॉम्प्लिकेटेड होता था, लेकिन उसका खूबसूरती इतना होता था, माने उसका एस्थेटिक लुक इतना अच्छा होता था कि सब लोग चाहते थे कि ऐसा ही बने. तो जहाँ हदीद, आप लोग जहाँ हदीद के बारे में भी गूगल में सर्च करेंगे तो उनका बहुत सारा मास्टर स्केच सब है. तो उनके द्वारा जो एक स्केच ब्रिज का बनाया गया उस पर आपका शेख जायद ब्रिज दुबई का बना हुआ है, जो देख लीजिए कितना खूबसूरत दिख रहा है. ये शाम के समय लाइट में है और ये ऐसे. ब्रिज केवल हम लोग माने ऑब्स्ट्रक्शन के ऊपर ट्रैफिक को पार करने के लिए, मटेरियल को पार करने के लिए ही नहीं बनाते हैं। ब्रिज का देखिए यहाँ पर एक हाई एल्टीट्यूड पे बनाया हुआ ब्रिज है। इसमें एक विंड टरबाइन लगा हुआ है और इसके जो डेक है उस पे सोलर सेल्स लगे हुए हैं। तो ये लगभग 1,15,000 घरों को पावर सप्लाई भी दे रहा है। ये हमारा चेनाब ब्रिज जो रेलवे पे बना हुआ है, रेलवे द्वारा बनाया अभी तक का हाईएस्ट रेलवे ब्रिज है पूरे वर्ल्ड का, जिसका ग्राउंड से 359 मीटर हाइट है। ये हमारा केबल स्ट्रेट या एक्स्ट्रा डोज ब्रिज कहिए, क्योंकि इसका पाइलन का हाइट बहुत ज़्यादा नहीं है और इसमें जो केबल्स हैं वो फैन टाइप का नहीं है। ये आर्च ब्रिजेज है। मटेरियल का भी जो हमारा स्टील में हाई स्ट्रेंथ स्टील आया, ये स्ट्रैंड बार है, इसका ये क्रॉस सेक्शन है। जो केबल्स हमारे जो लगे रहते हैं केबल स्ट्रेट ब्रिज में या सस्पेंशन ब्रिज में, वो केबल देखिए इस तरह का कॉम्बिनेशन ऑफ जो छोटे छोटे वायर्स हैं, कॉम्बिनेशन ऑफ वायर्स, उसी का ये केबल बनता है। गुड जजमेंट कम्स आउट ऑफ एक्सपीरियंस एंड एक्सपीरियंस ऑफन कम्स आउट ऑफ बैड जजमेंट। तो डिसीजन लेने में चूकिए नहीं, गुड डिसीजन हो या बैड डिसीजन हो, वो आगे आपको फ्यूचर में जज करने में सहायक होगा। थैंक यू।
Thank you so much, sir, for your invaluable guidance and for deepening our understanding of this critical subject. Now I'd like to call Prashant Ranjan Malviya, sir, to present vote of thanks.
So I would like to thank head of the department to provide me this opportunity to give me this vote of thanks to Engineer Singh. Engineer Singh is a very well-known face in the field of bridge engineering, and recognition is already given by Bihar government, which we can see. He is a technical advisor in BRP NNL. And sir, let me tell you, your in-depth knowledge in bridge engineering has inspired us previously also, and today also we got to know much more. That too with beautiful examples. Like we got to know, like sir stated from starting, sir stated the evolution of bridges. So let me tell you, sir, that evolution of bridges over ages, as discussed by you, is our evolution of our knowledge in the field of bridge engineering. Like time to time you are coming here, you are attending us, you are giving your experience, and that is very valuable for us, sir. And your discussion on this, sir, aerodynamic shaping, that was really like how the history comes, that particular section which sir taught us, which sir told us, that was really fabulous, sir. We got to know much more, and that is making us more keen to know about bridge engineering hereafter. And there is a quote, sir, like experience doesn't come with ages, it comes with explore. So that is what we can get from you, sir. So I extend my grateful thanks to Engineer Singh, Technical Advisor BRP NNL. And thank you, sir. Thank you for joining us in our international conference. Thank you once again. Thank you, sir.
Now I would like to invite Praful Kumar Sharma, sir, Associate Professor, Civil Engineering Department, to present memento to Engineer Sanjay Kumar Singh, sir. Moving on, I would like to now invite B.D. Adu sir, Professor in charge, Eco Club, and our esteemed alumni of Civil Engineering Department. Sir.
Thank you so much, professors. So now, without further ado, let's explore the topic mechanisms and practicality of alkaline activation of waste glass for soil stabilization with Dr. Ruola Kaltazari. I am truly delighted to share that Dr. Ru is a mining and geotechnical engineer with over 15 years of experience. He currently serves as a senior lecturer and associate head of School for Learning and Teaching at Auckland University of Technology. His research, funded by over $300,000, focuses on innovative geotechnical solutions. We are glad to have him here with us. Thank you.
He'll be joining with us online, so stay tuned. We'll be getting connected with him very soon.
Good morning, everyone. I'm Dr. Ru Kaltazari from Auckland University of Technology in New Zealand. Today I'm excited to share insight into our research on the mechanisms and practicality of alkaline activation of waste glass for soil stabilization. This work is the result of a collaboration with my research team, as you see, Sarah Bayandor, Yusuf Adib, Elmira Haksar, and Rashid Nasari from different institutes. And this work is aligned with the effort to reduce the carbon footprint of construction and geotechnical materials and achieving the sustainability in construction and civil engineering. Here's the outline of my speech. We will first explore the application of alkali activated glass as a sustainable binder for soil stabilization. Following this, I will explain the underlying mechanisms of stabilization of soil using alkali activated materials such as glass. Then I will present findings from our experimental investigations into soil stabilization with the binder. And I will also review a comparative life cycle assessment of the carbon footprint of alkali activated binder versus traditional lime and cement stabilizers. Finally, I will discuss the challenges, opportunities, and future of alkali activated materials. Sustainability is a main topic in modern construction. Soil stabilization is essential for infrastructure development and construction, but often it involves environmentally problematic methods, like use of cement and lime in soil stabilization. Locally activated materials, or AAMs, address this issue by reducing the amount of carbon footprint by incorporating waste products such as glass waste or fly ash or GGBS binders in the process. The use of these materials will be beneficial because it helps managing the waste, and also it reduces the need for exploiting raw materials. At the same time, it lowers the carbon footprint of the practice. So this is aligned with the UN Sustainable Development Goals in terms of construction development, soil stabilization, waste minimization and management, and sustainability practice. Soil stabilization is a method to reduce or remove the problems with problematic soils. For example, if you have low shear strength, high permeability, high seepage, liquefaction problems, slope stability, or low bearing capacity, we can use one of the soil stabilization methods to eliminate the problem. This could be mechanical, biological, or biochemical and chemical stabilization techniques. The ones that we discussed are the chemicals, traditional stabilizers like cement and limes, and non-traditional stabilizers like alkali activated materials. As you see here, traditional stabilizers are demanding of energy, and also they produce a lot of carbon footprint or emission, because the lime in the process is disintegrated into CaO plus CO2, and almost half of that will be converted to CO2 in this process. While cement and lime have been reliable stabilizers, they come with some substantial issues in terms of environmental costs. Cement production alone accounts for 5 to 8% of global carbon emission. And the increasing demand for cement makes this problem even worse. Traditional methods also require high energy, as we saw in the previous slide. So further solving the resources. These challenges shows us the urgency for adopting sustainable alternatives like alkali activated materials. As you see, the demand for cement is increasing based on the predictions until 2040. And also, you can compare the historic per capita global cement demand industry per person in 1917 versus 2000 and 2020, which is significantly increased. Alkali activated materials, on the other hand, have proven to be effective in lowering the CO2 emission compared to cement. But the amount of reduction is different in different reports by different researchers. So as we see throughout the years, we have different or versatile values for that one. But in general, depending on the binder type that is selected, the mix design, the location of the project, and the application of the alkali activated binder, it could be between 9 to 97% of saving in carbon reduction. AAMs are produced by combining precursors such as waste glass or industrial byproduct or waste with alkali activator like sodium silicate or sodium hydroxide or potassium hydroxide or potassium silicate. And there are different materials like natural and processed minerals that could also be used in alkali activated materials as precursors. The cost of the alkali activated materials could be different, depends on the type of the activator that is used and material that is processed. It could be 90% cheaper to 48% more expensive than the ordinary Portland cement. There are different types of alkali activated materials based on the amount of calcium in the system. As you see, if you have high calcium or if you have medium calcium or low calcium, there will be different names for them. And the geopolymers are usually the ones that come with a lower amount of calcium. This is the process of alkali activation and also the result of that. As you see, based on the amount of calcium and also different elements in it, like magnesium, there will be different products created by this process. This is an example of the state of waste glass recycling and reuse in different countries. As you see in New Zealand, for example, a very large number, 73% of the glass is recycled, but still there is a huge amount of that going to the landfill. The amount that is recycled is used as aggregate, and it's a low-tech application that could be enhanced by using it as a precursor or activator in the alkali activated process. This is the same for other countries. As you see here, alkali activated binder stabilizes soil through a combination of chemical and physical mechanisms. The alkaline activator reacts with the waste glass to form a strong matrix that enhances the mechanical property and durability of the stabilized soil. As you see here, the waste glass could be sent to landfill or could be crushed, and then the glass powder is created from the crushed glass to be combined with alkali activator, add mixtures and additive to create the alkali activated material or the binder. The binder is then mixed with the problematic soil to create the stabilized soil, the end result of the stabilization process. Our first case study focuses on stabilizing pumice soil, which are abundant in New Zealand's North Island. This is a commercially available pumice that we use in this research to represent the pumice soil. Microstructural analysis of pumice, together with its mineralogical properties, are shown here that represent the unique behavior of crushable pumice, which is a problematic soil in New Zealand. To stabilize this soil, we first designed an alkali activated mortar using waste glass by including different percentages of activator to precursor and testing them through mechanical test of UCS properties. So the unconfined compressive strengths of different mixes after curing were examined, and we selected the optimum one, which was 0.4 activator to precursor content. Then we further analyzed the particle size distribution of the precursor, and the optimized version was the one that used activator to precursor of 0.4 and the ratio of ground glass 0 and ground glass 20, which are two different particle sizes of ground glass as precursor. This optimized mortar then was used with the problematic soil pumice for stabilization process, and the result have been achieved by the UCS tests. Different percentages of the precursor versus aggregate, or the binder versus aggregate, were used. The one that uses 30% of precursor versus the aggregate or the pumice was not successful because it was too dry. But the 0.4 and 0.5 achieved good results. As you see here, the 0.4 of precursor to aggregate achieved more than 500 kilopascal, and the one that had 0.5 of precursor versus aggregate achieved around 1.5 megapascal of strength. After confirming the mechanical performance of the stabilized soil, we also conducted a comparative analysis of life cycle assessment for the alkali activated soil versus the soil stabilized by lime and cement. And the result shows that the alkali activated glass binder produced 21% less carbon dioxide than cement and 15% less than lime. So this demonstrates the potential of this binder as a sustainable alternative for soil stabilization projects. Our second case study explores the stabilization of loose sand using alkali activated glass binders. Areas with deposits of loose fine sand and silt in New Zealand's South Island have experienced multiple disastrous liquefaction phenomena during Canterbury earthquake sequence in 2010 and 11. This ongoing research involves strength tests, microstructural analysis, numerical modeling to validate the application of this technology in mitigating liquefaction. The findings will expand the application of alkali activated glass binder to diverse soil types. So we had experienced the successful stabilization of pumice. Now we are going to use this for sand stabilization as well. This research demonstrates the successful utilization of waste glass in the production of alkali activated binder for soil stabilization. This binder not only enhances the soil properties, but also contributes to sustainability by reducing the carbon footprint. By advancing this innovative technology, we can move closer to a more sustainable and eco-friendly geotechnical industry. In conclusion, while cement and lime have been effective stabilizers in improving soil performance, they come with significant drawbacks, including high energy consumption and substantial CO2 emissions. Alkali activated materials or binders, on the other hand, present as sustainable and eco-friendly alternatives. They offer comparable performance while requiring less energy and producing fewer emissions. The use of waste glass as a precursor in alkali activated material also further enhances its environmental benefits by reducing landfill waste, preserving natural resources through a decrease of demand for raw material extraction, and also lowering the environmental footprint associated with mining and cement production. Also, this emerging field offers a promising pathway for sustainable soil stabilization practice. Alkali activated materials were introduced in 1908, and the research blossomed only in 1990s, which is very recent compared to cement, which have been around for 150 years. So while the potential of these materials is significant, they have to overcome several challenges. These include standardizing test methods, improving rheology and curing controls, and also studying long-term durability of these materials. Addressing these challenges, we required collaborative research, industry partners to invest in this research, and also policymakers to fully raise the awareness and discuss the benefits of this technology. This schematic illustration of key steps of commercializing alkali activated materials provided by Provis clearly pictures the roadmap for future work in this environment. And these are some real-world applications of alkali activated materials that have been successfully implemented in practice. This is a residential building that used alkali hydroxide activated blast furnace slag in 1960. This 24-story building used alkali activated furnace slag concrete in 1986 to 1994. And also there are several applications in road and transportation and also airport runways. This picture is the application of the alkali activated material in retaining wall, freeway, and this one is the precast bridge. Thank you for your attention and interest in this work. I hope this presentation has provided valuable insight into the application of alkali activated glass binder. If you have any questions or wish to discuss this or any related research, please feel free to contact me by my email, and hopefully we can together continue this path of innovation and sustainability for the geotechnical application of alkali activated materials. Thank you very much.
Thank you so much, sir, for sharing your valuable
Dear
knowledge.
everyone, it's my great pleasure to
Sorry. Thank you so much, sir, for sharing your valuable knowledge on the mechanisms and practicality of alkaline activation of waste glass for soil stabilization. Your insights have really enhanced our understanding of this innovative approach and its potential in sustainable civil engineering practices.
Now moving further, I would like to invite Dr. Dongsheng Shu from Wuhan University of Technology, China, to speak on deformation monitoring of super high-rise buildings using multi-GNSS PPP methods. Sir, please.
here to give my presentations. Thanks very much for the RISC 2024 committees, and especially thanks for Professor Shukla to invite me to give me this chance to give my presentations. I'm Xu Dongsheng from Wuhan University of Technology, China. Today, the topic of my presentation is the development of deformation monitoring with fiber optic sensors and GNSS in geotechnical engineering. I want to divide my topic in the 5 parts. First is I give very brief introductions. Second, I give some our research about the absolute deformation measurement with GNSS. And the third part, I give some relative deformation measurement with fiber optic sensors, especially FPG. And the fourth part, I give some field application examples. And finally, I give my conclusions. As we know that nowadays, the increased frequency of sudden and localized global disaster globally has been significantly influenced by the global climate change and the socio-economic activities associated with urban expansions. You can find there are many examples of collapse of the slopes, foundations, and some disasters, especially in China. And the trend of landslide disasters and slope failures increasing recently in China, which creating an urgent need for scientifically sound and rational disaster preventions for the mitigation and management. Normally, for this disaster prevention, build a smart city system is a quite effective and efficient way. There is a typical structure for the smart sensing system. They are including 4 parts. The first layer is sensing layer, which you install some different sensors, monitoring the water, deformation, and cracks. And then the IoT layer, you will have some data acquisition and transmission of the data. The third layer is called computing layer for the data analysis and slow stability calculations, and then go to the application layers. So today I will focus on this sensing layer. We have developed some monitoring about the deformations in absolute deformation and also relative deformation with GNSS and fiber sensors. So first I'll give some examples about how to measure the absolute deformations measurement with some GNSS method. As we know, the global navigation satellite system GNSS has been high accuracy and all-weather capability, full automations, high sample rate, and low interface requirement between stations, which can be, there are many different GNSS, such in China we have the Beidou systems, in GPS, global, and Japanese, in India, different type of this satellite. So this data can be used for high-rise buildings, stems, bridges, slopes measurement of the deformations. This deformation is based on the absolute deformation measurement. The Beidou system itself has a position accuracies at the meter level, which cannot be used for the deformation measurement. So we need to assistance of reference stations and other actual factors. So the accuracy can be enhanced to centimeter or millimeter levels, so which can be used for precision or deformation measurement or safety monitoring. So we have different stations. So with these stations, we can decrease the measurement errors, and this station can be found for the station network. So today we will share with you how to build some position principles approaches. So our receiver can be get the unknown position observation satellite with known positions. The position of the satellite we can understand. So we can use these three distant measurements. It's possible to calculate the latitude, longitude, and elevation of the point, which we know these formulas from different satellites. We can understand these positions. So normally we only need three satellites. We can get the 1 point, these parameters. But if we have more satellites, this measurement accuracy can be increased. So normally in GIS in China, in every point, if we have the satellite, can get access to satellite for the more than 30, so we can get good accuracy. So for this formula, which we know that we can, for the GPS payloads, we can get this different satellites can combine. So we can use the GNSS satellite or also with GPS satellite, or we can combine different satellites together. So for the globally, we will need to consider about the errors and the delay of the delay errors together. So this normally we have two combinations, loose combination and tight combinations. So for the loose combinations, you can only get the different satellite from different countries. But if you tight combinations, you can get more data together. So in this study, we are build or refine model constructions. In the deformation measurement, with this significant abstraction, the refined singular to noise ratios can be decreased the measurement errors. So for this model, I will do not explain the detailed models you can find in our published papers. So we are refined this model constructions. We reduced this measurement errors. You can see the measurement errors can be reduced with some refined model constructions, which can be refined to less measurement errors. Also, we build extraction deformation signals, use GNS coordinate time series to reveal the deformation calculus of civil engineering infrastructures. So normally this deformation, you have the trend, paradoxical, step, and noise. You have different parts to combine. So this times you need to use some Fourier transformations. You get this different part, separate different part of this time series, and use this precision position method. You can understand if there is some parts of the railway or some disturbance. You can get this measurement disturbance from this data. So normally we are also establish the structures to receive the data, and you have the chips to install some the measurement approaches in these chips, and then you have the battery. This data can be communicated with different points. So we built this one with some hardware and software can be incorporated in these platforms. So we combine this together. We build this equipment. This equipment is built including this part, different parts. Some the hardware chips and the battery, and also this LoRa can transfer the data connected to different points. And also we establish this software can get all the data automatically, and then you can get this data together. So the most important thing is that you need to establish the stochastic models to reduce the measurement errors. So after reduce this measurement errors, this data can be used for the deformation monitoring. I'll give you some examples. We are do this test in our university. This is the equipment which we are installed in our these buildings. On top of these buildings, we have this received the satellite signals, so we can measure this data different time, and also we do some calibration test. We do some movement in this equipment, and then you can get this data. So you can find this the result of this measurement is high accuracy with some millimeters. Still, you have some measurement errors here. Also, if you can do some more deep analysis, you can find this equipment here. You can have some also have some measurement errors here. You can find some errors because of this disturbance of the cloud or some electronic interference. So there are some little errors. Mostly you can find from this data, time series data, you can get a good result of the accuracy. So from this one, you can get the displacement, and it's a good way to measurement the absolute deformations in the civil engineering. And the third part, I will give some sometimes the GNSS measurement approach is not very high accuracy. But if you need to measure some crack or small deformations, you need some more high accuracy. So for this type of high accuracy, we prefer to use some FPG sensor, fiber optic sensors. The fiber optic sensor can be used for measuring some relative deformations, not absolute deformations. So fiber optic sensors is based on the fiber. So fiber is normally to use for the transmit of the signals. But if you along this fiber, you make some break, some change of the index, reflection index. So there are some input signals, there are some reflect signals. So according to these reflect signals, you can measure the strain, the deformation strains. So this is the reason why the fiber break gratings can be used to measure as a sensor. It's a sensor. So for the sensing principle is based on the inject light. If there is some inject light into the fiber, some reflection of the wave. This wave will be shifted according to the strain and the temperatures. So if there is some temperature change or strain changes, so this wavelength will be shifted. So according to this shifted, we can understand the strain or the temperature change. So this is the physical video of the fiber sensors. So the working sensing principle is based on the wavelength shift. This is called wavelength shift. This is called the initial wavelength. So the wavelength shift and the initial wavelength has a relationship with the strain and the temperature. So we know this coefficient of C epsilon and the coefficient of the temperature. This coefficient can be get from the result, and also this coefficient is keep constant from the whole measurement. So this is the reason we can understand the strain and the temperature according to this wavelength shift. So from this structure, we can, from the optical sensing interrogator, we can get the wavelength shift and also initial wavelength. So from this formula, we can understand the strain and the temperature. So this is the working principle of the fiber optic sensors. Actually, there are many different approaches to fabricate, how to fabricate the fiber optic sensors. So we have different type of approaches. Some called it drawing, face mask method, and UV method. So from this UV light, you can change from the face mask method. You can make this fiber optic sensors. This is the fabrication system of the fiber optic sensor grating fabrication platform. For the fiber optic sensors, there are many different types. Sometimes for the temperature, DTS, and the FPG for the temperature, strain, and the vibration, and also distributed BOTD or BOTDR for the temperature and the strain, and also actual weak fiber break grating sensors. which can measure temperature, strain, and vibrations. This different type of technology, which are both called the fiber optic sensors, but they have more specific for the temperature and specific for the temperature, strain, and vibration, different functions. And also the distance, the measurement distance are more or less different. The accuracy is already different, and also the economic, the cost are already different. So normally we will select a different technology based on your different project purpose. But this fiber optic sensor cannot be used because they can only measure the strain and the temperature. So in geotechnical engineering, we are more focused on the displacement or deformation. So how to measure the deformation based on FBG, fiber black grating sensors. So we developed this device. This device was developed by our team. So because we want to measure the cracks or the deformations between this point and this point. Because if you measure the 2 points of the crack, you cannot directly use the FBG sensor because the FBG sensor is very fragile. It can be damaged, and also it cannot measure very relative different deformations. So we developed this device. This small device is the physical device is like this one. In this device, we have some spring, and we have this is the fiber black grating sensors. So inside we have some protection. So this protection, this one can be easy to be installed in this device in the field. So in this field, if there have some relative deformations, this strain will be happened here. So if you measure the strain, you can understand the deformation in these 2 points. And also you can use this spring to adjust the measurement range. So this is the formula which we developed to measure the deformation. This is the deformation about these 2 points. And this is the relative wavelength shift of the fiber optic sensor. So through this formula, we can measure the deformation through the shift of wavelengths. So the whole device was fabricated by the 3D printing method, FDM approach. Can be easily printed, 3D printed. And also the fiber optic sensor can be embedded in this device. So this device is very good, can be measured the displacement of in different points based on the fiber optic sensors. So we do some calibration test. We change the displacements, and we found this relationship, the wavelength shift, so we can understand the displacement sensitive factor is 2.3 nanometer per millimeter. This is the sensitive factors. And also we have this sensitive index, because the linearity, resolution, and hypersensitivity, repeatability, and total accuracy is 5%. We do some calibration test in this oven. We increase the temperature, and we see the wavelength difference in this temperature calibration test. And also in the same designs, we proposed another design principle in this to measure the deformations, large deformations. For large deformations, you need to measure the strain. So normally, if there is a large deformation, the fiber bracket sensors cannot be extension for high or large strain. So we developed this device to convert the large deformation to small strain and deformation. Because we convert this deformation into the bending moment of this beam. So you can understand the deformation of the beam related to the displacement of the device. This is the displacement. This is the deformation of the beam So they have some relationship. And according to this one, you can understand the wavelength shift of the FPG sensor related to the deformations. And we do some calibrations about these parameters. Different parameters, we do a lot of calibrations in the FEML model to check which is the best parameters. And then finally, we develop this device. This device we fabricated in our lab. This is the road. You can change the deformation, the length, and the diameters. And also you can change the spring, so you can get different measurement range. So also we do some calibration tests. We find the displacement sensitivity and also the sensitivity index of these different transducers. For another one, we also do some dynamic vibrations. Dynamic vibrations is also important in the geotechnical engineering. So if this is the dynamic vibrations, this spin will be changed. So we establish this FPG sensor in this spin. So if this is the pressure, there is a vibrations. So you can measure this vibration of this spin. So we develop this transducer. This is the transducer we developed. And you can see this small one is this applied pressures. And inside you have the FPG sensors inside. So you can measure the strain, and also we build this relationship, the dynamic, the shifted wavelengths according to this wavelengths, and you can get the pressures. F is the pressure, and also you have this relationship. If they have some vibration here, you can get the result of the loading and the vibrations. And also we fabricate this one in the FDM approaches. And also we do the calibrations for different parameters. You need to choose which is best parameter for your device. And also we do some calibration test in the laboratory, and also we do some different sensitive test, repetitive test. Also we made a small model, physical model. In this model we have some water inside, and here this is water inside and the impact loadings. We can measure this the dynamic loadings in different stage. We have different stage, you measure the loading response. So this is the result. We get the result from our device. So this device can be measured the dynamic loadings and the deformations, and also you can measure the pressures of the in geotechnical engineering. So in different time you can get the different measurement, also the water pressure distributions, and also the changes of the deformations in different parts. So we do this analysis. It's good in the water environment conditions. In the first part, I will give some field application examples. So the first one is the tunnel deformations, because in the this is happened in the Wuhan Metro Line 8. So in here we need to measure the converged deformation monitoring based on the multi sensor technologies. So we use the fiber optic sensors in different points. We are connect this point. We want to measure the convergence. So we use the fiber optic sensors with different points. We have different wavelengths. So we also to use the PIV approach to do the compression. And also you can see this fiber optic sensors. You need to convert the strain with the deformations, and then you can get the errors. So the errors is quite less, and different loading stages you can get the different deformation shapes with the fiber optic sensors. And another example is about to measure the micro crack monitoring of rock mass based on high process and small range of displacement measurement device. So in China nowadays we have different type of these structures. We have some crack, small crack inside. So the government want to understand how this crack developments. So in these cracks, we are installed this small displacement crack device with fiber optic sensors. We are installing different points, 1 to 10, 1 to 9, and then temperature sensors. So this is a sensor we are developed in our group. So we are installed these small sensors in this point, and in different places we have the different wavelengths. And also we installed the temperature sensors. So these sensors can be connected in one cable, and also all the cables can be connected in the box. So this box can be automatically measure all the data in 24 hours, and we measure the data in one year. The software and also the data, all data can be connected, can be obtained by this software, and also you can analyze this data. So we give you some examples about our measurement data. So this the data is the less than 1 millimeter data, the deformations. From the 2021 April to the June, we have all this data deformation you can find. Especially we found some sudden changes. So why this happened? Because there is a high rainfall. There is a rainfall, so there is the deformation changes. So we give this data to the manager. So they are do some reinforcement. They understand that there are some small 0.0, I think 0.05 millimeter. So deformations because of the rainfall. So this data go to the manager so they can do some reinforcement. Another example in the field pavement. So in this pavement, we want to understand the internal crack and the internal deformations. So we are installed the different type of sensors inside of this concrete. So we have different type of sensors inside, and also you can find this data in different. Because of the data, we cannot give too much details. And also we can find some board pile. In this pile, we can also install these sensors, and we can get the temperatures and also the strengths. You can understand the crack development in different times. The third example is about the deformation measurement of board piles, which is quite often in geotechnical engineering. So sometimes you have this board pile, different board piles, and then when you do the excavations, you need to understand what the deformation of this board piles, why is it safety or not safety. So in different stages, you can see this excavations. So after this board pile is stored, and then excavations in different stages. So we are installed this fiber optical sensors in different depths, and we make a hole inside and include the fiber optic sensors inside, and then make the cement grouting inside together. So this is the field situations that we install the different type of fibers. You can find in these constructions, so the strain increased, deformation also increased. So the maximum lateral moment over the excavation depth comes to 0.05%. And also you compare this deformation with other examples, you can find that this deformation is relatively less. So it means this project is safety, no problem. This is the result of the deformation, maximum deformations in different stages. And also we can do some evaluation models. We want to understand the factor of safeties, because this is the deformation data. So if you want to, from this deformation data, you want to understand the factor of safety. So we build this model. We are to mode updating the parameters. We build this model to analyze the different excavation about the slope stabilities. And also we have this data of the parameters of stiffness. For different uncertainties, we consider about the field conditions. So we analyze these measurement errors and also the parameter errors. From this one we can get this the data of the maximum lateral deformation displacements. We can do some predictions, different predictions. And then more importantly, we want to relate this deformation of the foundations with the factor of safety. So when you know the deformations, you can understand the factor of safety. So this is good for the engineer. We can get the data and then tell them the factor of safety also. So finally, I go to my conclusions. So from this presentation, I give two technologies. One is the GNSS technology to measure the absolute deformation measurement. This can give some good result about the absolute deformations. Another one is the fiber optic sensors, which is measure the relative deformations. So a high precise deformation displacement can be measured with a lower device. You need to convert the fiber grating stream to the deformations with different devices, so you can achieve. And also the uncertainty of the geotechnical parameters should be considered. You can consider based on the base updating models. And based on my presentation, apart from my presentation, I want to give some introduction about the journal. This is our journal, the Journal of Earth Science, which is founded in 1990s, with SCI index is 4.1. If you are interested, you can see some papers, and also you can submit some papers. Welcome. So this is all on my presentation. Thanks again for your listening, and also thanks very much to give me this chance for my presentation. Thank you.
Thank you so much, sir, for sharing your valuable insights. Now, here's a short tea break for all of you. We'll just begin the technical session after 10 minutes. So, we are running out of time. So, we'll have very short break of only 10 minutes. So, by next 10 minutes, everyone is requested to please get over in the scene at your seats. Thank you. Also, there's one more announcement. Those who are having their presentation at 8:26, they can directly move to 8:26 for their presentation after the break.
No? इसका माइक उसमें चेक करेगा ये साउंड जा रहा है उस पे। और जैसे ये तुम्हारा वीडियो देख रहा था चल रहा है तुम्हारा वीडियो में ये वाला माइक का साउंड
So welcome back after the short break. Now we would be starting with the technical session. So let me brief you with the rules. So you'll get 10 minutes overall, out of which there'll be a warning bell at 6 minutes, after which you need to wrap up your presentation, and you'll get overall 8 minutes for your presentation, which means at 6 minutes you'll have the warning bell
Minutes to wrap up your
2 minutes
presentation,
to wrap up
and
your
then next 2
presentation,
minutes
and then
for
next
question
2
and answer
minutes for
round.
question and answer round.
And for this technical session, we have our chair. This technical session will be chaired by Dr. Rajesh Kumar sir, professor in the Department of Civil Engineering at IIT BHU, and the co-chair of this session are Abhijit Anand sir and Saroj Meena ma'am. So the first one, I would like to call Shubham Rana from MNIT Jaipur. Since he has not joined us, so he will be presenting later on. So we'll be moving on towards the next one, the fourth presentation, that is Chandrasekharappa Agnasalil, who is from BMS Institute of Technology, and he has written paper titled Integrated Approach for Urban Flood Assessment and Management of Vijayanagar, Bengaluru, using geospatial technology.
Hello.
Yes, sir, you are audible.
Thank you. Am I, sir? Audible?
Yes, you are audible. You can continue with your presentation.
Okay. Right. Can I present it now? Hold.
Yeah, you can start with the presentation.
Hello, sir. The slide is visible?
Yes, your slides, your screen is visible, but your slides are not.
Right, sir. Good afternoon. I am Dr. Chandrasekharappa Agasnali, Assistant Professor, and my colleague Dr. Deepak MS and Dr. Anup Kumar Agote. So, my today's topic is integrated approach for urban flood assessment and management
Sir, your
of
slides are not
Vijayanagar
visible.
area, Bengaluru.
Sorry to interrupt, sir. Your
So here are
slides
the
are not
contents.
visible.
First is the problem statement, significance, and the key objectives,
Sorry to interrupt, sir,
methodologies,
but your
and the major
slides are not
findings.
visible. Your screen is visible, but
So,
your slides are
then-
not visible.
Results and discussions. So here are the
Sir,
problem
your
statements.
slides are not visible.
In every urban areas, the flood source can affect worse by existing paved streets.
Sir, your
and roads,
slides are not visible.
concrete roads, which increase the speed of flowing of water, that is called runoff. So there are most of the place which is covered by impervious surface, right? So surfaces are prevented by the rainfall from infiltrating into the ground and thereby causing higher surface runoff.
Sir, your slides are not visible.
Anand sir, the slides are not visible.
No, your slides are not visible.
Just a minute, sir. Just a minute. Okay, the screen going with the. Share the screen. So now it's visible, sir. Full window. Right. Screen share, right. Now, sir. Now it's visual, right, sir. Let me repeat the things. And my topic is integrated approach for urban flood assessment and management of Vijayanagar area, Bangalore, using a geospatial technology. And myself, Dr. Chandrasekhar personally, and assistant professor working as assistant professor in BMS Stream for Technology and Management, Bangalore. And my colleagues, Dr. Deepak MS and Dr. Anup Kumar Egbote. So here are the contents, problem statement, significance, and key objectives, and there are methodologies, and there are major findings and results and discussions. So here is the problems. Every urban city, every metro cities generally, which affects the floods because of heavy rain, and also because of existing paved streets, more of concrete roads. So less soil and more concrete roads in every urban cities. So impervious surface prevent the rainfall from infiltrating into the ground, and which is causing the higher surface runoff that may be higher than the local drainage capacity, and assess the major causes of floodings. So the key objectives, this paper, to identify the flooding areas, the key areas where are the major floodings, and estimate the quantity of runoff of water for watershed, and compressing the study areas, especially the Vijayanagar areas. Assess the major causes, the floodings, and to recommend the feasible methods to deal with the urban flood waters. So whether it may be the administrative or maybe any other methods. To recommend the engineering and administrative feasible solution for urban flood waters. So here are the methodologies, the data collections from the ground, and generation of the various watershed, right? And generation of various thematic maps like topo maps, drainage maps, digital elevation model, digital terrain model, and land use land cover, and flow direction of the waters, right? And complete the land use land cover maps we have prepared. So runoff quantity estimations, there are different methods, right? And there are one of that SES Karum number method we use and recommended for feasible flood models. And significance are here. Runoff estimation is highly crucial for understand the magnitude of the what you call this capability of existing urban drainage system, which leads the better design for future improvising the existing ones. So exponential increases in the built-up areas, especially the most of the areas covered in Bangalore by residential areas, and the impervious areas, which requires a better assessment of the flood waters quantity to reduce the damage of life as well as the properties. Here is the location maps where we have this. So southern part of the Karnataka, and here is the what you call this location of the Vijayanagar area. And here are the elevation points, the contour points, elevation points, which are collected from the ground as well as from the Google, and which gives you the topography of the total area of the study areas. So with this elevation points, so we have generated the contour maps where we give the complete topography, whether it's a valley, hill, and is there any flat land. So if it is a valley areas, that area is completely covered by any kind of residential buildings or maybe industries. So as because of the metro cities, the infrastructure development, layout planning people, the most of the time, encroaching the open scrub land and constructing the buildings and residential areas, even in industry also. So because of that, the flood is happening even 1 hour of rain, you'll get the enough water to get into the flood. So here are the contour maps. So here are some of the photos. This is how the most of the year, every year there will be a kind of the floods. So every rain, every 1 hour of rain, the complete cities gets flooded because of this completely concrete road, pavement road. There is no soil to infiltrate the rainwater into the subsurface. That is because of the reason that the metro cities gets flooded. Yes. Here is the digital elevation model which you prepared based on the the elevations. So here you can see this, the drainage patterns, and here is the lowland areas where the most of the houses and some of the offices, they constructed the houses here in the lowland areas. So this gives us the most of the areas where we will get in the floods. Look at this here. Some of the work is happening, and even there is a most of the places are lowland areas. It's basin for each the drainages, the watershed catchment areas. And here are the drainage. So most of the place, look at this. This is a one watershed, this is another watershed. And most of the and here is the superimposed the drainage map into the watershed. So here it's clearly matching with the valley as well as the elevations. Here is the called slope.
You may wrap up your presentation
map.
now.
We are use the kriging method for the slope map. There is a SCS curve methods, curve number method, which you use it for estimation of excess runoff from the rainfall. This is Q is equal to PIA and squared. And
Sir,
Q is the
you may
runoff
wrap up
in
your
mm.
presentation now.
P is the rainfall. Yes, sir, yes, just it. So I is the initial abstractions, and the S is the potential maximum of retention of the rainfall begins. So Cn is the curve number. So here is the types of soil. So types of soil textures, runoff potentials, maximum rate of infiltrations, and water transmissions. Here is the table which gives you the clear idea of the what kind of soil, what kind of runoff potentials, and infiltration into the ground. So here is the curve number which you get. Cn is the curve weighted number, and the C1 is the curve number from the 1 to the n number, and A is the area of curve number, right? So A is the total area of the watershed. So here is the land use: agriculture land, plantation, commercial, industrial, urban, village, land, and with a scrub and scrub forest, canal, river, reservoir, and other areas. So here is a hydrologic soil group. We have made it by taking the sample runoff curve numbers as per the HCS land use land cover map. And here is the slope maps. So here is the slope maps. So the green method. Some of the photographs, the Bangalore, especially in the Vijayanagar areas, flooding areas. And here is the rainfall data which are analyzed thoroughly, and where is the which month is a more rainfall and which one is the less, and where we are getting the more flood, what could be the reason, what are the remedial measures. Here is the rainfall data analysis, annual rainfall data, right, from 1995 to 2000 and 2000 to 2018. So till that we have analyzed this, and here is the Now, the recent floods, especially happened in Bangalore city, and the results and discussions. So here is the major the problem in the Bangalore, especially in the Vijayanagar areas. Topographically, the area is completely undulating topography, and the most of the area is covered by the residential building and some of the commercial building also. And because of the area, complete area is covered by the concrete road and residential buildings, the water could not enter into the subsurface. Infiltration is less and runoff is high. Because of that reason, the entire water is flowing on the road, and wherever the lowland is, it's getting flooded. So that is the one reason. Identifying the flooding areas where there is a low land covered with the residential buildings, and even the local authority, like we call it as a BBMP, listed to vulnerable the flood points for the 20 to 21. The where said that moderately vulnerable under the watershed determinations process. Highest rainfall which are observed in the month of September generally in 184 mm, and the least in the month of January. So June has highest total rainfall comparatively other areas. And it's observed that land use land cover that covers the study areas with heavily built up areas. There is no space to infiltrate the subsurface. So that's completely the impervious ground, resulting in the flood vulnerability. According to the literature survey also, previous research also, the groundwater recharge and rainwater harvesting has been noted. First, enough capacities exceeds because of span of time, short period of time. So more the rain, so it gets choked. And the other reason is the completely concrete scenery things, and this increasing the flood vulnerability in the study areas. Right. Thank you, sir. Thank you, Anand sir, for giving this much opportunity to present my research paper and my international conference. Thank you so much, sir.
Well, now we are opening up to question and answer session.
Hello. Hello. Now it is open for question and answer discussions. Any of you want to have questions on this?
Any questions from the audience? Delegates?
Okay. I am Rajesh Kumar. From my side, the question is: it is related to your research proposal, a topic that you are going to take in your academic, or you are taking it from the industry. Hello. Hello.
Hello, Abhay sir.
It is audible to you?
Yes, sir. Right. Sir.
So
right.
my question is related to your research area. If this is your part of academic, or you have taken it from industry, or is a consultancy project?
So most of the area is covered with the concrete roads, sir. Concrete and the residential building. That is the first reason. Second reason is the lowland areas where they're completely covered by the residential buildings. They should not construct those houses and commercial building in the lowland areas. Those two major reasons, the getting the floods.
What should be
only the administrative role can play a very important things here.
What should be the replacement of concrete? Suppose I want to have a plain area or some finished area. So instead of concrete, what should be there as a materials as per your thoughts?
Right, that's true. That's correct. You're right. But still, if you take any metro cities, this is the reason. So deforestation is the major things, and infrastructure development. Rapid infrastructure development can lead the flooding things in the metro cities.
My question was related to replacement of concrete. Do you have any idea that concrete can be replaced with some other material so that it will be pervious instead of impervious?
Exactly. That is one of the valley which covers in the Bangalore. Bangalore, there are five valleys.
Sorry to
Five
interrupt.
valleys
The
we have.
question was
Kormangala Valley, Vijayanagara valleys.
the question was related to replacement of concrete.
Yes, true. That is in the commercial. I mean, that's in the heart of the city areas. Yes, that is in the heart of the city areas. The only the administrative
Okay,
reason we can
we are
avoid
concluding
it
with the
and we
presentation.
can complete the.
Thank you. So moving on further, I would like to now invite Rohit Raj from BIT Sindri, who has written paper titled Performance Evaluation of Natural Coir Fiber as Soil Reinforcement.
Good afternoon, everyone. Myself, Rohit Raj, Research Scholar, Department. Myself, Rohit Raj, Research Scholar, Department of Civil Engineering, BIT Sindri. Today, my seminar presentation is Performance Evaluation of Natural Coir Fiber as a Soil Stabilizer. Overview of my presentation is at first introduction, objective of the present study, material description, methodology, material property, test result, summary and conclusion, finally references. Soil stabilization. It is the process of increasing the strength, bearing capacity and overall performance of the soil by the use of controlled compaction and the addition of suitable admixtures or stabilizers. Methods of soil stabilization, mainly two methods. Mechanical method. In this method, we stabilize soil by use of compaction, consolidation, and by well grading. In chemical method, we mix any additive or suitable admixture for soil stabilization. For example, lime, cement, bitumen, fly ash, coir fiber, etc. And in this research, we use coir fiber as a soil stabilizer in this research. 5 minutes. ठीक है सर ऑब्जेक्टिव ऑफ द प्रेजेंट स्टडी yes sir sir at first find the geotechnical properties of collected soil sample and find the change in geotechnical property after addition of coir fiber in different percentage and find the optimum dosage of coir fiber. Sir, methodology, material property. In this, find the geotechnical properties of black cotton soil. Sir, physical property of coir fiber which is provided by supplier. Sir, standard protector test. Sir, in this test, at first we find the OMC and MDD of soil, which is 1.70 gram per cc and 17.70 at 17.70 water content. Further mix soil with different percentage of coir fiber. Then I found that the maximum dry density increases and OMC decreases at 1.5% content of coir fiber. After again we increase the coir fiber, then MDD start to decrease and CBR test result on different percentage of quartz fiber. At first we find the CBR value of expensive soil, which is 4.48%. Again we increase the percentage of quartz fiber with different percentage, and I found that after 1.5% of quartz fiber, again we increase the percentage of quartz fiber, the value of CBR start to decrease. UCS test result obtained from expensive soil with different percentage of quartz fiber. In this result, at first we find the UCS value of soil sample, which is 310.23. After that, we mix different percentage of quartz fiber. At first, we mix 0.5% of quartz fiber and find the variation, and finally maximum value at 1.5% of quartz fiber. Again we increase, then start to decrease UCS value. Finally we conclude that this is the graph. So finally we conclude the optimum dosage of quartz fiber is 1.5%, because at that percent the CBR value, UCS value, and optimum and maximum dry density is maximum.
Now it is open for question and discussion. Any of you? Yes, go ahead.
Good afternoon, everyone. My question to you, sir, is: can coir fiber be combined with other reinforcement materials such as geotextiles to improve performance?
Already quartz fiber is a type of geotextile material.
It's a natural one.
It is based